The question I have is, could you do an example on calculating stresses in a horizontal deposit of soil? We did one example in an earlier video. In this example, we'll learn two new things. One, we'll learn how to deal with capillary pressure in calculating stresses. Two, we will learn how to calculate values for appropriate unit weights of the soil from properties such as degree of saturation and void ratio and use them in the calculation of stresses. In this example, there is a surface pressure of 10 kilopascal. Relevant properties of these three layers are given, and we are to calculate the stresses at point A and point B. Our approach is going to be the same as before. We want to first calculate the total vertical stress and the pore pressure at these 2 points, and then we can calculate the effective vertical stress, and from that we can calculate the effective horizontal stress, and then we can calculate the total horizontal stress. So to begin the process, we need the total densities for the three layers. So let's do that first. If you recall, this is the expression we had for the total density, and this expression is valid for both unsaturated soil and saturated soil. If the soil is saturated, all we have to do is to substitute 1 for the degree of saturation. So here are the calculated values for the total densities. Let's first consider point A. The total vertical stress is calculated as shown here. Sigma V equals density of layer 1 multiplied by the thickness of layer 1 plus density of layer 2 multiplied by the thickness of layer 2 plus density of layer 3 multiplied by this distance right there, which is 4 meters. And now you need to add the surface pressure of 10 kilopascal to it. So the total vertical stress works out to be 184.2 kilopascal. The depth of point A from the water table is 8 meters. So now you multiply 8 meters by the density of water in order to calculate the pore water pressure at point A, which works out to be 78.48 kilopascal. Subtract one from the other to get the effective vertical stress at point A. K naught for layer number 3 is given as 0.5. So you multiply the effective vertical stress by 0.5 in order to get the effective horizontal stress at point A. Now you add pore water to it to get the total horizontal stress. Now you repeat these steps to calculate the stresses at point B. Only thing you want to be careful is that point B is in the capillary zone, and therefore the pore pressure there is going to be negative, and you use this distance 1 meter in order to calculate the pore water pressure. So the pore pressure is calculated to be minus 9.81 kilopascal. The remaining details are similar to what we did for point A.